Hello, everyone. Thank you for coming to today's talk. We have Maxim and Munsif. They're going to talk to us about authentication, roles, and permissions in the edX platform. So a warm welcome for these guys, and take it away.
Thank you. Hello. Hi, so I am Munsif. This is Maxim. We both work at OpenCraft. And we're going to be talking today about authorization in the OpenEDX platform. I know lunch today has been a bit heavy, so we are all looking into that sweet nap. And since this is a long and complicated talk, we're going to help ease you into it. Now we're going to try and make this exciting. Okay, so this is the agenda for today, and we have this QR code. If you want to scan it and follow along in the slides, please do. Okay. People are still scanning? Okay. All good? Okay, let's do it. So as you all know, people want three simple things in life. They want good food, they want to spend quality time with their loved ones, and of course, they want to learn about the authorization model of their favorite online learning platform. And I'm not talking about Moodle or Coursera. We're of course talking about OpenEDX. So let's get some basics out of the way. We need to define first what we mean when you say authentication and authorization. And the cool way of saying it is auth-n for authentication and auth-z for authorization. So auth-n is basically answering the question, who is the user? We want to know who we are dealing with. We want to verify their identities. And we usually do this in OpenEDX with the auth-n MFE or the legacy login page. Once we have done that, once we have authenticated the user, we need to know what can this user do. And this is what authorization is all about. So it is which permission can we grant this user, which actions can they perform, be it generic actions such as accessing a page or creating a resource, or a specific action, such as accessing a particular object, or updating it or deleting it. And authorization can be delegated through OAuth, and this is something that is done often in OpenEDX. So let's first talk about auth-n. So as I said previously, this happens in the auth-n MFE. The user usually enters their username or password and email and password. And it is also possible to do it with third-party authentication. So we have authentication through SSO providers such as Amazon Cognito or Google or your personal organization authentication provider. And once this is done, the system knows who the user is. So the following things happen. The most important one is there is a user state, a session that is created in the server, in the backend. It's represented by a unique identifier that is linked to our user, and this is basically the state we have of our user in the backend. So in each subsequent request, we would need to have this piece of information sent by the user, and the best way to do this in browsers is with cookies. So there is this session ID cookie. In addition to that, there is a JWT, that's a JSON Web Token cookie that's set. And it contains a payload that has information about the user, such as their username, their password, their roles, the expiration date of this token. And an interesting information is that the JWT in OpenEDX is split into two cookies. So there is the payload one that contains all the information and that is accessible by JavaScript. And there is the signature, because the JWT is signed cryptographically with an asymmetric key. And this one is an HTTP only cookie. So it's not accessible by JavaScript. And we do this to prevent it from being tampered with. So these two cookies are merged later by middleware, and they give us a normal JWT. So when I try to think about login, it seems like this complicated thing that's very convoluted and complex. But when you boil it down, at the end of the day, what is it? It's just the user telling the server, giving the server some identification information, the server verifying that and saying, okay, here's a piece of state, and they set it with this cookie header. So login, at the crux of it, at the heart of it, is simply this set cookie headers. And these information will be sent back by the browser each time they make a request. And as you can see, this is the session ID that will uniquely identify the user and allow us to get the session information. And the two split up JWT cookies. The bottom one is the signature, and the header is contains the payload. Okay. So, as I told you, the JW2 is simply a JSON web token. It's a JSON object that looks like this. It has my information. It has my ID. It says whether I'm an administrator or not, whether I'm a super user or not. It can also have a list of roles or claim, as they are called. And then all this information is signed by the server, and when it's sent back with each request, it can be cryptographically verified. So that's the JSON web token. Once the user has done all the learning in the world and improved their skills and used our platform, they gotta log out. And this is done by simply clearing these cookies. So this is what happened behind the scenes when the user clicks log out. It's simply the server deletes their state information and sends back these set cookie headers, which clears the cookies. So any subsequent request won't have that particular information, and the user will no longer be identified. So that's what happens for login and logout. It's just cookies. It's just information in the backend that identifies our user. So let's talk about authorization. I'm not sure if you know this, but OpenEDX is built on top of a very famous web framework. It's Django. It's not a very well-known fact, so I'm sharing this info with you. I hope you make good use of it. But jokes aside, OpenEDX makes heavy use of Django's authorization. And Django's built-in authorization is really powerful. So we have users, we have groups, we have permissions, and the user can be assigned to different groups. And the permission could be assigned to different users and groups, and a user inherits their group's permissions. And each time a model is created, the default country auth backend creates permissions for that model. So with each migration, we have default permissions, and we can use the default backend to check for permissions. And that is actually what is used in OpenEDX. As we can see in the slide, we have the if not user has perm enroll in course, and this is all default Django authorization mechanisms. Then if it's not, we do our thing. So the Django default authorization package also hooks into the default Django admin console, which is one of the Django's biggest selling points. So as we can see here, we have the LMS and the studio administration consoles, and they are pretty similar. They slightly differ in which apps they have. For example, we have course creator, which only lives in studio, and we have, for example, third-party authentication, which only lives in the LMS. These two consoles are heavily used in Django to do different configuration. For example, when we want to set up enterprise, we rely on the admin console. When we want to configure third-party authentication, set up SAML, SSO, all this stuff is done through the console. We can have super users who has the super user flag set to true that can access basically any aspect of the admin console. But we also can have staff users that can be granted specific permission to different admin apps. Yeah, I think that's about the Django admin. So unfortunately, the default Django authorization backend doesn't offer any object level permissions. So what does that mean is that by default, if a user has the permission to change a model or to delete a model, they will have the permission to delete all instances of that model and all objects related to that model. And this is really not that flexible. And the community offers multiple alternatives. OpenEDX recommends and relies on Bridgekeeper, which you can see the picture. It's from Monty Python. Bridgekeeper, which is a custom auth backend that allows us to handle object level permissions. It even allows us to do more, because at the heart of it, it's simply a rule class that has a check function. And this function can have any logic. It can be backed by a database. It can be backed by information in different places of the code. And we hook in this custom rules into Django permissions. So as we can see in our slide, we have some custom rules from the OpenEDX Django apps. In this case, has access rule and has a role rule, which check if the user has a certain custom role or has a certain access, such as staff access. And we hook those into permissions imported from Bridgekeeper. And we can even combine those using Boolean operators. So in the last line, we see the vertical bar, which is basically a Boolean OR. We can also have AND, we can have NOT. And the power behind Bridgekeeper is that we have this authorization logic that is defined in this custom rules, or we even have built-in rules that allows us to check based on the objects and database attributes or on foreign key relationships. And we compose these rules together and we hook them into Django's built-in permissions, then it just works. So that's really why we rely on Bridgekeeper for our Django's permission in OpenEDX. Yes. So with the advent of single-page applications and React and OpenEDX embracing all of that, RESTful API got more popular. And OpenEDX embraced that trend and relies on Django REST framework to have its different RESTful APIs. DRF, Django RESTful framework, is like the perfect candidate for that. It has great documentation. It integrates beautifully with Django, the default ORM, and Django in general. It has serialization. And for our purposes for today, it has great authorization and authentication support. And as we can see in the slide, we have a list of authentication classes. In our case, for example, because we rely on JWT authentication and on session authentication, we can compose any type of authentication. And we also have a list of permission classes, which are like authorization classes that decide whether the user can have access to different RESTful endpoints. So we have multiple built-in interesting ones, such as is the user is authenticated built-in permission class, or there is admin user, or even the Django model permissions, which hooks into the default Django generated permissions. But once again, these don't handle the object level permissions. And luckily, DRF allows to extend and have our own custom permissions. As we can see here, we have this is-course staff instructor permission, which inherits from the base permission, and we have an object level check has object permission function that checks permission on object level. And as we can see in the arguments, we have the object passed, and based on that, we can check whether the user has really access to that object and can perform the action on that RESTful endpoint. And it is really flexible, so we can even have the granularity of deciding which permission class can be applied, which permission can be applied to which HTTP method. So we can map, for example, the get method to a particular permission and the put method to another one, and much more. Okay. Now let's talk about course roles. I think it could be argued that it's one of the most important aspects of authorization, as it has to do with the business and feature aspect of OpenEDX. It governs like what aspects of the course and how are they accessible, like if a whether be it courses or discussions or the instructor dashboard, student info, and much more. These roles are shared between the LMS and the CMS, so they share the same database table behind the scenes. And these roles are implemented and hooked into Django using the Bridgekeeper as well. And as we can see here, for example, we have the allow student to bypass entrance exam, which is based on whether the user has the instructor role or the data researcher role or any kind of roles. These roles can be added from two different places. Mainly from the LMS, where we can assign roles to users, all the roles to users. As we can see here, we are trying to assign the beta tester role. We can also assign roles from the CMS, but unfortunately only the staff and admin ones. So in the CMS, it's more staff and admin roles. In the LMS, it's all the roles that can be assigned. Roles could be daunting, course roles, because there are many of them, and this is a table of some of the most important ones. One way to look at this table is that we have two big categories of roles. The two first ones, which are like admin and staff, and they allow users to have pretty much all of the access to the courses, such as accessing Studio, creating and editing content, accessing the instructor dashboard, and mostly everything. The difference between the two is that admin, in addition to staff, compared to staff, can have the right to grant and revoke access. So that's for the admin and staff roles. Then you have student and student plus, if you will, roles. So basically the students can simply access the courses after the start date and post in forum discussions. And then you have some student plus kind of roles, such as the discussion moderator, which is a student that can help moderate the discussions. You have also the beta tester, which can have access to roles before the course starts, which has access to courses before their start date. And finally, you have the data researcher role, which can have access to the data tab in the instructor dashboard. And this is more to perform data analysis and things like that. Finally, one of the most interesting aspects of the OpenEDX authorization is the edX RBAC. And this addresses a very interesting problem. So if you think about it, OpenEDX is a collection, is a group of multiple microservices of a group of independently deployed apps, such as the LMS, CMS, e-commerce, discovery. And sometimes we want to handle authorization in a consistent way across different services. So how can we enforce this authorization across services that don't necessarily share a database? And the way we can do that is using this technique where we store roles in the JWT, in the JSON Web Token. When we log in, there are some what we call system-wide roles, and these roles are encoded in the token, and then each time a specific service wants to translate permissions from the system-wide role, it can by reading it from the JWT and translating it to a feature-specific role. So think of it like this: we have system-wide roles defined during login time and encoded in the JWT. Then each service has access to this list of roles that are encoded in the JWT, and they map it to local permissions and roles, to feature-specific permission and roles. So what happens is we define the role once on system-wide capacity, then each service, each feature can make use of it on a local capacity. And this is how we can enforce like role assignment in a system-wide fashion, and each service can decide how it can make use of this role. And this is what we call implicit access. And edX RBAC, the library, the module has different functions to perform this. And it is already used in enterprise. It's also used in e-commerce. And you can see an example in this code. For example, you have a system-wide enterprise role that can be defined in the LMS. Then it could be used by a different part of the platform. And the value is extracted from the JWT, then compared against feature-specific logic. So this is used here. It's also used in e-commerce. And it's really a powerful way to distribute authorization. And I think that's all I have to say about this. And I'm going to let Maxim talk to you about some more fascinating stuff.
Thank you. Hi, guys. Huge kudos to Monsa for sharing a higher level overview of the authorization and authentication in OpenEDX. And in my part, we're going to dig deeper or look at the almost lowest level which exists in terms of authorization and look at the building blocks of it. I'm going to have less jokes, but more code. So yeah, if I talk from here, does it pick it up? Cool. So we can start with an example of how you can implement a role in OpenEDX in U1. And we also had to go through experience of doing it, so we can take one of the implementations as an inspiration and example. So clients often come to us and ask for custom roles for them because they are not satisfied with default roles, or they want certain behaviors or certain permissions. Some of them are unique, some of them are similar to what already exists, but still we need to alter it. And one of the recent examples which we ended up implementing was a client came to us and said that they want a role which is very similar to core stuff, but they want some permissions to be revoked. And we ended up calling it limited core stuff. So as you can see, they wanted to limit the role from being able to enroll and unenroll students, assign or unassign roles, and they wanted to restrict them from being able to download student data. And we could implement a new role from scratch, but as you can imagine, that would take a lot of effort. It is totally possible. The caveat is that you would need to find every place in the system which checks for the role or permissions, and add the code there to check for the new role. And at the very least, it's not only like boring and takes a lot of time, and you need to be careful to find all the places. It also is bad design, because you're essentially modifying the code which should be doing something else. Like if you don't want to modify the enrollment code each time you want to add a new role. However, we can see that there is an overlap with an existing role, core stuff, which has loads of permissions, and we only need to remove a small subset. So it would be a great idea if we could somehow inherit from that role and reuse it in many places, but then just add tiny exceptions somewhere. So it's a bit foreshadowing, but that's what we tried to do. So let's kind of work from the fundamentals. This is how the code looks when you're trying to check for roles. On the screenshot, you can see 3 roles. And the most important part I want you to take away from here is that we basically, for any role, we just check. We call the hasUser method and pass a user there and see what it returns. And the hasUser method is implemented in a role-based class. Almost all the roles in one way or another, if they need access to the roles which are stored in a database, they call this method. And again, there's lots of code on the screen, but the most important 2 parts are this, like role cache. I don't think you can see that. Like role cache. Is that better? Yeah. So role cache is basically is necessary because there are so many places in the system. There are so many places in the system where we try to check permissions of roles, and if we didn't cache it at all, it would be very bad. The performance penalty would be huge. And later we see that we call hasRole method of the role cache class. So let's look at it. So on the screenshot, you can see the implementation of the whole role cache class from around a year ago. I'll tell you why it changed later. And we can, in the init method, the only thing we need to assume is that it just gets all the roles of the user. And then later, you can see that we iterate over like the whole list of the roles of a user. And then we try to check, like, does the role, course ID, or org match to what was passed to the method? And basically that way we kind of try to find if there is a role which matches what was passed to the function. So since we're trying to find a way where we can hook in and simulate inheritance, I think the most interesting part of this is this, like the role. So, and this is what we will end up modifying. However, an important thing to note is that the role here is a string. It's not a class, it's not an object. We cannot do is instance of or use Python inheritance somehow to leverage polymorphism. We have to work with the strings. which is slightly challenging. So again, we'll start from the beginning of how we started implementing that role. I first want to show you how the core staff role looked like, or looks like in general. So it inherits from course role class. That's how it gets, like, has user method and stuff like that. Then it also has, it is wrapped with a decorator. And this decorator existed before we touched any of the code. What it does is basically collects all the classes which it wraps and gathers them in one structure, which it then exported, and other modules can import it and look at the list of all the roles which are, like, which exist in this file. So we can somehow leverage that as well. And then the last important thing is that the string which we saw in the last slide, like the dot role, this string is taken from here. So in the last method, if we were passing a staff, yeah, this is what basically would be checked. So slightly lower, you will see the implementation for the course limited staff role. The inheritance, like the fact that we inherit from the core staff role, is irrelevant. It doesn't really do much other than provide us with default implementations for some of the methods. But other than that, it doesn't help us with any of the matching for the roles. However, the important thing is that we also, like, add the decorator, and we can look at this part. So the decorator is self-explanatory. We just add it, so it's added to the collection. But then we overwrite the role field with the new string, which is relevant to this role, which is limited staff. However, we add a new attribute which didn't exist before, base role. And in this attribute, we'll be storing the strings for the parent roles. So yeah, this is where we started. So now we somehow need to make some mechanism which will pick it up, right? And we start with modifying the decorator. We create the global structure, which will be storing our inheritance, or like pretend inheritance. And then later we modify the decorator in the same file. We add this part, which basically the only thing it does is that it checks if a class has a base role attribute, and if it does, we add it to the structure. And the way the global structure looks like is the keys are the parent classes, the strings of the parent classes or parent roles, and then the value is a set, and the set contains the strings of the child roles. So it's like a tree, more or less. So we have now the collected or created the structure which stores the inheritance. We somehow now need to make sure that the code which checks for the roles somehow uses this inheritance. And so this is a screenshot from the role cache class. If you remember before, it was quite simple, only required like a few lines of code and only had 2 methods. So now we had to modify it. First, we add a new static private method, which basically allows us to get all the roles which theoretically could match a past role. If you look at this, it takes our new structure. It uses the get method to get all the children classes. So imagine we passed a staff string to this method. It would give us all the children classes, like limited staff, maybe we added something there, more there, and then it joins it with the role. So if let's say we passed a core staff here, it would return a set of 2 roles, core staff and limited core staff. And later, we modify the hasRole method to basically, we change this part. Instead of comparing the strings directly, we check if the set which was returned by the get roles contains the role which we're trying to find. Actually, no, it's the other way around. We check the list of roles the user has against any of the roles which could match, like with inheritance and stuff. So this is kind of it. It kind of works. At this point, a limited core staff role would have all the permissions of the core staff, which is great. It didn't take a lot of code. the good part is that it would also work with BridgeKeeper. We didn't have to go with a solution because with the BridgeKeeper we could have used a different way of doing it, because BridgeKeeper allows you like composing different roles to match against, right? However, we were kind of lucky with the fact that what you're seeing right now on the screen is a screenshot of one of the rules of the BridgeKeeper, which we use internally. And you can see that at the very bottom, it checks against the same roles. So basically, all the BridgeKeeper rules now also work for this, even though we didn't have to modify any of it, which is nice. And the very last thing we need to do, since the limited core staff now has all the same permissions as core staff, is we need to limit it. We need to revoke some of the permissions which the core staff has and we don't want it to have. I'm sorry for the screenshot, but the important thing here is really these two lines. The only thing we do here is we check if the role is limited core staff, do not let them enter the studio. And that is it. This is how we added a new role. One thing I want to know is that later we had to add a new thing, which is called strict checking of roles. And the reason we had to do it is because of the edge cases, certain edge cases. One of the edge cases you could imagine is if you need to explicitly make sure that the user has both roles, let's say core staff and limited core staff. It is not very practical example, but things like that do come up. And you need to be able to check it, especially with like BridgeKeeper because of the way it works. And everything I showed you was actually upstreamed. It like you can check out the links for the pull requests. One is for the adding new role. The other one is for adding the strict checking. And we were even able to add more roles. However, those were not upstreamed because it contained data or like things which were only relevant to one client, so it didn't fit the upstream. But the limited core staff exists in OpenEDX now, and you can use it, and you can even add it through UI, unlike other roles. Like there are organization level roles which do not have UI, even though they work and you can totally like use them. They do not have UI, that no one knows how to use them. But yeah. And I would have loved to end on a positive note, but unfortunately this approach has flaws. First one is we had to introduce or simulate inheritance. We could not use like the default Python inheritance. We could not use any of the like existing things. We had to introduce our own structure, which is not intuitive. It is not self-explanatory. You kind of have to look into the code to understand how it works. It's not very complicated because we only introduced a few things, and you could really just read one PR and understand it. However, it's still not great. We still had to insert code to restrict the existing role. And we would also have to do it if we wanted to extend it. So we did not solve the issue of having to inject code where it's not, shouldn't be injected. It made it better because the number of places we had to do it for was reduced by a lot. Like if we had to go and add a check everywhere where core staff is, that would be much worse. However, we still have to do it, and now there is like one check somewhere in the system where the studio login is to check, like, you know, for limited core stuff. Strict role checking, as I said before, it is necessary for edge cases, and I think that without understanding well the internal mechanisms of how role inheritance now works, it's very hard to reason about, and you can really shoot yourself in the foot when you try to combine several rules using BridgeKeeper. And since we're talking about permissions, it can be dangerous. You can accidentally grant someone access to something they should not have to, like data download or something like that. As a conclusion, in our implementation, we were fighting against the limitations of the existing implementation, and we did not see how we can overcome them without like some grand refactory of the code. So, yeah, OpenEDX has some problems with roles and permissions, and we were not the first ones to discover that. By the time we were doing the discovery for implementing new roles, it turned out that you were also recognizing the issue of the roles and permissions, and they were actively working with it, and it so happened that we got in contact and were discussing things. We were granted access to one of the documents which they did as part of a discovery. It is a 3-page document where it's full of bullet points where each bullet point is one of the problems. So you can imagine 3 pages of problems they're not drastic problems, it's points of improvement, right? And I'm not going to read the whole document, it would be too much. But just to give you some taste of it, like I'll show you two. One of them is like, for example, if you don't have access to Studio, but you can still log in. Any user in OpenEDX can log into Studio. They will not see any UI. It will be just like it's a broken workflow or like user story. They can still log in, but it doesn't work. Thankfully, it doesn't let them through further. And another one, quite interesting one, since clients often come to us, they want to ask for a custom role because different clients have different ways they want to operate, and they have different ways they want to assign their staff. Like they need more control over the roles. And right now, the only way you can add a new role is by modifying the code. And even that, you saw there are lots of limitations with that. However, in theory, you could refactor it in a way that would allow them to add the roles during runtime using UI or using like admin panel. It is possible. However, right now it's not, unless we refactor. And I also want to highlight problems which we've discovered during the example which I showed you right now, and which we as developers, not just like people who use OpenEDX, not the course authors, not the clients, but developers, what we struggle with the existing implementation of roles and permissions. First of all, there is a huge lack of documentation. Many of the roles are not documented anywhere, and unless you read the source code, you will not know about them. And even then, from some of the discoveries which you did, I genuinely saw comments where a developer would find the role, but he could not confirm if this role works or not. It's not, I'm not saying anything about the developer, I'm saying that it's not intuitive, and sometimes it's hard to reason about this code. And every time a client comes to me and asks, what roles exist? I'm like scratching my head, okay, where do I start? And I only talked about LMS and CMS. There's discussions, discovery, e-commerce, like some parts of just LMS and CMS have their own roles. So it's like, the problem exists beyond just LMS and CMS. There's no consistent API. Different modules use or create their own functions, which are essentially wrappers around the building blocks, which are roles and permissions. However, you still have to figure out what the original developer intended and figure out which functions you want to use or not, what's the convention. Every repo has not repo, but every module within OpenEDX has slightly different convention. And you also have things like DRF, which you need to write different code for it because you need to wrap around roles so that the views can pick it up. And there are many examples like that. You would be surprised how many ways you can check whether a user is a staff or not. It's like around 9, that's a lot. And when you're writing code, how you can imagine the anxiety the person is feeling, which out of the 9 ways I should choose. At least in the scope of staff, it's almost all comes down to dots is staff. They always, if you follow the code, it always comes down to that. So yeah, no consistent API. Roles are not composable. I just showed you we had to introduce inheritance. However, even that is still not enough. Ideally, composability would allow us to use several roles to create a new role, even just one. And then at the end, you also can add or overwrite or delete certain permissions. Right now, it is possible, again, but with many limitations, and we want it to be better. And last one is roles are not extendable. If we would, for example, take plugins, there is a mechanism where you can basically ask edX platform to install your plugin, and it will, during runtime, it will pull it into the system and plug it in, and it'll be fine. With roles, the only way for you to add a new role is to modify the code, and then if it's substreamable, you're in luck. If not, you have to maintain a fork, which for like when you have so many different variations and combinations of permissions, just for a name limited core stuff, you can, like, every organization which will have their own interpretation of what the limited core stuff is. We can of course fix it with feature flags. I hope I don't need to explain, but it's going to be a nightmare if we do that. So yeah, ideally you would have a mechanism where you would say, like, okay, install this repo, and this repo we have like roles, and the OpenEDX pulls those roles, and they work in runtime, and it's all great. And then, and again, it would be too sad to finish on such a sad note, right? Like, because there are so many problems apparently. Like I only covered less than on the first page of the document. Fortunately, as I told you, like 2U were working on it, and they had a great plan. They had a solution. Unfortunately, this solution was paused in February of 2024. However, there is still the item or the ticket on the OpenEDX roadmap, which you can visit. I encourage you to visit because I'm not going to be able to give it justice. Like, they have lots of documentation and a plan, and they start executing this plan. And they also have, at the very bottom, you have the link to the, you can see their dev branch, which has a lot done. It's not all, but has a lot done. So their plan was quite interesting. They were able to, like, at least 2 things they've done would have changed the roles and permissions greatly. The first thing is that they, instead of having the roles in the code, they moved them to the database. And it is a great thing. It is not great for discoverability because you need someone with the skills of, like, SQL querying to be able to graph, like, which role corresponds to which permissions. However, as a trade, you get runtime permissions which you can modify. You can create UI for the organizations, or like teachers, admin staff, like, to be able to create new roles. You can revoke, add new permissions on the fly, and you can back it up. Like, you can do a lot with that. It made it much more dynamic instead of static, and it also lowered the ceiling of, like, being able to create new roles. The second great thing they did was, so you've seen Bridgekeeper. One, at least in my opinion, one of the great things Bridgekeeper allows us to do is to decouple permissions from roles. The problem with roles is that if in the code you check for a role, each time you add a new role, you need to add this role to this check. It makes the maintenance of the code like a nightmare. However, if you check for permission, and then there's some sort of mechanism which checks, oh, does this user have this permission? And roles are kind of a list of permissions. That makes the code much more maintainable, flexible. Like, you can add new roles, just tell them, oh, this role has this permission, and it instantly starts working in all the other places. So their plan was to use Bridgekeeper to refactor all existing code, which is a grand task. What you can check out, you can see the diff on the link, in the last link on the slide. What they were doing, and you could see that, is that each place which checked some permissions or roles, they would keep it in place, but then they would also add a new check. So the plan was that eventually, once they cover all the checks, they can go look at this diff and remove all the old checks, and in one night switch to the new permissions checks. And yeah, unfortunately it wasn't finished. However, it is still up. The code quality is quite good. There's lots of documentation, including the ADRs, and it's all there available. And we hope that this project doesn't get abandoned, at least not for long. And, like, as a community, we can pick it up and refactor it, because I think many people, or we think that everyone will benefit from it. All developers, maintainers,
users.
Yes, the schools and universities, their staff, their admins, and yes, it looks like, oh, but just developers complaining, but in reality it has, like, much further implications. So yeah, that is it. Thank you.
Thank you for your attention, and I hope you enjoyed your nap. I see. I'm sorry, we are not taking questions. No, please go ahead.
We don't have much time, but you can chase us at the coffee break or email us at, it's basically our first names, at opencraft.com.
Yeah, but maybe 1 or 2.
Could we start merging some of those changes to the Bridgekeeper checks right away? Because there's already Bridgekeeper in the platform, right?
So what they did is they created a new app. It's called Course Roles or something like that. I think we could, but I don't know what is the coverage of tests and stuff like that. I only looked at like what they've done, what was the approach, right? But you can definitely check it out. Sorry, the link is somewhere there.
Yeah.
Yeah, basically, if we can break it down and start making progress.
Yeah,
on
that'd be amazing. Yeah.
No, can I just add quickly? There is already an ADR in OpenEDX to migrate to Bridgekeeper. It's like 2 or 3 years old. Their plan was to do it incremental. It got abandoned. So that's the fear of doing things incremental, is that you just add a new API which will get deprecated, will stay, and it will create a new like nightmare.
Yeah.
Okay, JWT, the payload is, I think it's base 64 encoded,
Yeah.
but it's not encrypted.
Yeah, it's not encrypted. Yeah.
It is not.
Yeah.
Is there a way to encrypt that, to have encrypted cookies? We've received complaints about that. So it's a security issue to have a cookie. It has personal information, it has your email, your name. I wonder if there's
I'm really not sure about that because it's an RFC. Like, I'm not sure if there is like a version where it is encrypted.
But did you not say that there is like 2 cookies, one with the data and the one with
Yeah,
the key?
that's just for protecting for the data integrity. Like, it can't be tampered with, and we are sure like it's valid. But for encrypting it, I'm really not sure. Yeah.
I mean,
Which is the RFC? Do you remember?
It's just like JSON Web Token. Yeah.
yeah, you can maybe add custom code to it. Like you can always tamper with it, but yeah.
I believe one of the reasons is because that data is accessible by the JavaScript to the list of roles, and it's used directly. So if it was encrypted, there would be a need to decrypt it, and it brings in a whole lot of issues. Yeah.
Since you seem to be experts on the subject,
We're not.
on the proposal, you certainly looked at it. How much effort would you gauge is left to finish it? How much work does it involve? It seems like a lot was done.
Yeah.
Do you have any idea how much work is left?
Do you have any contacts to you? We could ask them.
Well, we could. Yeah.
I mean, ballpark, 300 hours at least. So it's like a lot is done. Like the fundamentals are definitely there. There is app. They've done a lot for Bridgekeeper. They converted many of the previously roles to permissions. So like there is a list of permissions for certain apps. However, like you can guess I don't know, but how many apps there are just in LMS, right? For each, you need to go take every check and break it down into a list of permissions, and then like basically convert it. Maybe you can do it with ChatGPT faster.
No, I don't think so. But essentially, replace every mention of a role in the code in a code check with the permission,
So
and that's a
so
pretty
the
extensive portion of the code.
Like
Sorry.
accurately estimating it is as much as doing it. You know, like
Yeah.
like is as long like if you're already looking at the code, you could be doing it, right?
It's about finding each instance and converting.
Yeah.
Yes, yeah. But it's not hard. It's actually like you just grab for has user, has permission, or some variation of that. Like you can take the list of roles and grab for all of them, and more or less you'll find like 99.9% of them.
Yeah.
If you still have time. So
Please.
yeah, first midway through the talk I was like thinking through all the use cases that I have encountered when working with the enterprise stack, and there is one particular use case that I want to highlight where if you want to log into one of the services that enterprise stack has, which is like I think enterprise access or enterprise subsidy, something like that, the documentation says make sure you log into an MFE first before you log into this particular admin interface, Django admin interface, because the only way that Django admin interface gets the user ID, which is the numerical ID, is by parsing the JWT token. So I just want to highlight that because that's how gnarly it is, the permissions implementation is, and the dependency on the JWT token is, at least for enterprise stack that I have familiarity with. And now with that in mind, my question is, what would it take to keep the roles as is and migrate to a database-based implementation, and then rewind it to permissions later on at a slower pace when when time comes by? Because when setting up things like system-wide roles, like we have a OpenEDX operator or enterprise operator role that I use in enterprise, which cannot be easily defined as permissions because it defines different things in different contexts. So what we have done is basically mark it as a super user and just forget about it because it's doing everything in the background. We don't know what its permissions are at the moment. So what would it take to keep the roles as roles in the database as the first iteration and then break it down to permissions at a later point?
I can answer
Yeah,
that.
go ahead.
So the thing is, just moving it to database doesn't make sense because let's break it down. Existing roles have a class. I think I dropped it from the slides, but it's like course access role or something like that. I can show it to you. It's already exists, and it basically used, like if you remember, I was showing a slide where we iterate over all the roles. Those roles are taken from the database.
Yeah.
So that's, you don't need the roles to be in the database. You need a mapping between roles and permissions.
Yeah.
And that's what the new project was doing. They created 3 tables: roles, permissions, and mapping between roles and permissions. That third table is what you need, which means that you need to convert, you need to create permissions and like add the code to check for those permissions. So just like, if I understood your question correctly, just moving roles to databases would not work because already
Roles are already in the database, yes.
Sorry,
Yeah.
what I meant was you move both roles and permissions into database, but the current checks can they continue to coexist, or like can they continue to be checked on roles? The checking doesn't have to be moved to permissions. Is that something that's possible? Because
It could be done gradually, but the idea is like to only check on permissions, and permissions could be composed into roles. So think of permissions as Lego blocks, and the role is a composition of permissions. And that's how you get the flexibility to have your own roles and very customizable and extendables one. Yeah.
you can always, like you saw you kind of, if you follow the slides, you can find all the code places we modified. And I think what you're trying to do, you can kind of hack your way into that, like find the mechanism and like insert some code there that if it's this, always let it pass, right? You
Yeah.
can do that. It doesn't mean it's upstreamable,
Yeah.
right? But I think if you want a shortcut, it could be done like that. Yeah, I hope this answers your question.
okay, yeah, it does. Thank you.
Yeah, it's considering that contributing a new course role is not a repeatable process, and as you mentioned, you have to maintain forks to do some of the custom roles that you've implemented. Do you think that we as a community can do something to make it more extensible? Maybe building something on top of OpenEDX hooks, or what kind of support do you think we need? Because I think one of the items that were considered in the platform roadmap that was being built by TU is exactly extensibility and building something, very customizable.
Yeah. Well, if I understood your question correctly, since the idea was to move roles and permissions to the database, all you need to add a new role is to have some SQL script, which would inject new role, which is possible with tutor. Like you can add a tutor in each job, which would add. So it's already it would be pluggable enough. The only thing I'm worried about as a dev is that with code, you can have a static check, right? You can reason about the code and its logic. With SQL, it's just like, you need to make sure you don't edit twice and other stuff. But otherwise, it would be already extensible to the point where we wouldn't need forks.
Yeah, but that's the proposal. That was what was being implemented, exactly. So with what we currently have, do you think that we in some way can support that? Or
I'm not sure. I think it is such an integral and essential part of the code that it would be too hacky, I guess. Yeah, I don't know.
Yeah, you can do something like check the roles, like the same thing as with plugins or Django apps, right?
Yeah,
I think you can add a similar mechanism for it in the, I don't remember the name of the file, but where the LMS roles are.
Yeah, permissions.py.
You need to add some sort of hook, maybe, which would allow loading roles in runtime. This is definitely possible. My concern is that it moves the things away from the proposal, and it just extends the time we're going to be stuck with what exists. But yeah, it is possible, and I hope this answers the question.
Sorry about that.
All right, guys.
Thank you.
Thank you.
Your laptop.